Assalamualaikum and good morning to Dr. Tamrin and all my fellow friends. Today our group from group 2 will present about the fish disease monitoring, which is a mini project that we have agreed to share and make this assignment is microbial activity sensor. Next, we will move to the next slide. This is our group member, which is myself, Muhammad Hazrul, and Muhammad Fauzan, Roshani, Patzila, Adrina Lawrence, and lastly Amanda Pearl.
Fish diseases are considered one of the biggest risks to the economic of aquaculture worldwide. Based on Miller and Mitchell 2009, fish diseases are caused by bacteria, virus, protozoan, and metazoan. Among these four causes, bacteria are responsible for most of the infectious disease in farm fish. Fish larvae counting is typically done manually, which is difficult for large sample datasets. Researchers have developed techniques for faster and more efficient fish counting. Based on our Luden et al. 2020, computers technology offer an alternative to manual counting for determining fish larvae survival rates, assessing fish stocks, and monitoring fish population growth. A faster, simple, and scientific method is needed to collect fish size data. Based on Howe et al. 2015, if we using machine system, it is non-destructive, rapid, economical, consistent, objective, repeatable, quantitative, and robust. It is also capture and analyze image in real time to make decision based on results. While traditional measurement methods have weaknesses, it is time-consuming, inaccurate, cause stress to fish, and reduce appetite, which will hinder growth.
For this slide, this is the problem statement that we have knowledge before this. Then this mini project is related to fish aquaculture industry. Is an essential industry that greatly contributes world food security. However, microbial infections caused by pathogenic bacteria can be harmful to fish health and economic losses and lower output. It will affect all the aquaculture industry. So this is the three type of problem statement that we have knowledge and find out. First, the challenge of detecting fish disease in aquaculture due to the lack of necessary infrastructure for early identification, Ahmed et al. 2022. Second is the effective, stable, and efficient microbial biosensor for detecting toxin, pollutants, and chemicals, Park et al. 2013. For the third is the routine fish disease monitoring program to ensure the health of fish, improve fish hatchery efficiently, and minimize disease outbreak. For the next slide is objective. They have three objectives. First, to develop a microbial activity sensor. Second, to identify early stage of fish disease. Thirdly is to integrate sensor data with alert system.
Moving to our overview of design, this is our flowchart of our microbial activity sensor for fish disease monitoring. We start by measuring microbial activity in the water. If the microbial activity reaches a dangerous level, the system will display the data on a board for monitoring and also predict future trends to help with yearly detection. If the microbial activity is not at a dangerous level, the system will activate a warning system to alert users of any potential risks.
So I will be presenting about the product detailed description for the drone. The first component of the drone of this product is a camera, which is purchased from the store. Next is water resistant casing because we do need to protect the camera from being submerged in the water. So the material for this will be HDPE or plastic, and the color will be black. Next is water resistant lens cover. Again, another protection for the camera, especially the lens, because without it we cannot record underwater. And the material for this will be fiber or HDPE. Next is cable tie, which we will use to connect certain parts of the product together, certain components. Next is the multi-parameter, which will be used to obviously test the water quality. And last but not least is the drone, with the components of the drone being the body, the blade, and the wings. And the material will be fiberglass or
The
plastic.
next slide is the component. They have five segment for this component, which is structural component, power system, control and communication, multi-parameter sensor, and additional component. Okay, firstly, I will talk about the structural component. It have a camera, water resistant casing and lens, drone body, and blade or propeller of the devices. Next is power system, which is a rechargeable battery management system, BMS, and power distribution board, PDB. And that is the control and communication of the devices, microcontroller, flight controller, which is content for these devices or drone. It have a Wi-Fi module, GPS module, electronic speed controller, ESC, and brushless motor. And it also have the multi-parameter sensor that included in the devices, which is, for example, it can detect the pH, this of oxygen, temperature, turbidity, ammonia, nitrat, and microbial activity. And lastly, the additional component for this drone is the waterproof connector, propeller guard, LED indicators, data storage SD card, and cloud storage if it need a backup system, as you can see the example in the slide.
Next is the material selection. As for the camera and accessories, for underwater camera housing materials is commonly made from polycarbonate, which is a strong plastic, or aluminium. So polycarbonate is more affordable but bulkier, while aluminium offers better durability for frequent use. And for the water-resistant casing material, it is typically constructed from fiber or HDPE, a high-density polyethylene, which provides good resistance to water and impact. And then for the lens cover materials, it is often made from a combination of HDPE, plastic, and fiberglass, ensuring protection against moisture and environmental elements. And then for the drone components, as for the body materials, it is usually made from a combination of plastic and fiber, providing a lightweight yet durable structure. And next is the blades material. So the blades are typically constructed from plastic or fiberglass, so this helps to balance strength and weight for optimal performance. And lastly, for the wings material, similar to the body, the wings are often made from plastic or fiber, contributing to the overall lightweight design of the drone.
Today I will be presenting about the mechanism of the drone. So the drone is used for disease monitoring and testing water parameters. So the camera on the drone will actually detect disease by observation. For example, if the fish has rugged fin, cloudy eyes, or it has erratic swimming behavior, we are able to observe it properly. Next is it is also able to test water parameters because obviously there is a multi-parameter attached to the drone. So this multi-parameter will test qualities like dissolved oxygen, pH, and etc. Next is the drone connects to Wi-Fi for functioning. So this allows us to store data, for example, the videos from the camera and also the water parameters from each testing. So this way we can actually recap each day and we can have a, access to a history of the data. And we can see if the data from the video aligns with data from the multi-parameter. Furthermore, there is also an SD card input in the drone. So, for example, if we were to bring this drone to somewhere without internet access, we can still use it to store the data because it will be a backup for the drone. Last but not least, the drone is powered by battery because obviously it will be submerged into the water and we cannot use any electricity for water. So we will be using battery.
Next, so this is a simple sketch of our product, which is drone that function to monitor disease fish to prevent the disease from spreading and infecting other fish. In addition, this drone also equipped with multi-parameter tools that aim to take water parameter data such as pH, DO, temperature, conductivity or salinity, turbidity, total dissolved solid or TDS, ammonia, and many more.
And as for our budgets, for camera and accessories, the water-resistant casing, which in this case we're using refined TG Pro underwater camera housing, might cost around Rm 3,859 ringgits. And for the water-resistant lens cover, the prices for lens covers vary, but a typical lens may cost around 50 ringgits to 200 ringgits. And for the drone components, as for the body, a basic drone might range around Rm 500 to 2,500 depending on the specifications. And for the blades, the replacement typically costs around 550 to 900%. And as for the wings, similar to the blades, the wing can cost about 100 to 300 ringgits. As for the additional cost, the battery and connectivity, a drone battery usually costs between Rm 100 to 500 depending on capacity and brand. And lastly, for the internet connectivity module, if it is separated, it could range from 50 ringgits to 200 ringgits.
So the conclusion, the integration of drone in aquaculture monitoring significantly enhances efficiency by enabling rapid and wide coverage of fish farms. Compared to traditional manual sampling, drones provide real-time, high-resolution data acquisition with minimal human intervention. Equipped with YSI sensor and irrigation technology, drone efficiently measure critical water quality parameters such as dissolved oxygen, pH, temperature, turbidity, and ammonia level. This real-time measurement help to detect unfavorable conditions that could lead to fish disease. Additionally, aerial and underwater drone imaging combined with AI-based analysis allow for the early detection of abnormal fish behavior such as discoloration or mortality pattern, enabling fish farm to take timely action to prevent disease outbreak. So that's all from us. Thank you.